Morning, Year 10. Today we're going to look at exponential equations, but before we do, let's do some revision of our fractional powers. So question 1, we want to evaluate without using a calculator 144 to the power of a half. A power of a half is the same as a square root, and the square root of 144 is 12. In question B, we want to get rid of the negative power first by putting the indice on the bottom and changing it to a positive power of a half. Then we change the power of a half into a square root, and the square root of 16 is 4, so it will be 1 over 4. Question 2, evaluate the following without using a calculator. So the brackets that are there are not really important. They're just around the y's, but it would be y to the power of 3 over 4 times y to the power of 5 over 4. When you're multiplying things with the same bases, you add the powers. So 3 over 4 times 5 over 4, 3 plus 5 is 8 over 4, but 8 divided by 4 is just 2, so that's y squared. Okay, so here's our new work, exponential equations. A simple exponential equation is in the form of something to the power of x is equal to another number. So the a and the b are numbers, but what makes it an exponential equation is the power of x. Okay, a cannot be equal to 1 because then it wouldn't be an exponential, it wouldn't be increasing, because 1 to the power of anything is always 1. There is only one solution to exponential equations that are in this form. Many exponential equations can be solved by expressing both sides of the equation using the same base. So we will try to write them as a to the some power of x, because that was our exponential part, the x, and we want to have a to some other power on the other side. And then if the bases are equal, that means the powers must be the same, so x will be equal to y. It's an important strategy to get used to, because while you might find that some of the easier equations you may be able to guess the answers, the harder ones you won't. So you want to practice this technique from the very beginning. So question 1a. To solve the equation on question 1a, we have a 2 as the base of our exponential. So I would like to try to write 16 with a base of 2. Now you may know some of your base 2 numbers, or if you need to, you may get your calculator out and you might have a bit of a guess. You go 2 to the power of 3, that's not quite big enough. So if you go to the power of 4, you do get 16. So 16 is the same as 2 to the power of 4, and we still have 2 to the power of x on the left-hand side. If the bases are now the same, that means the powers must be equal to each other. So x must be equal to the 4. Let's try a slightly harder one. In part B, we have a base of 3 on our exponential. So I would like to turn the right-hand side into something with a base of 3. Starting with the 9, I know that 9 is the same as 3 squared. But I also need to get rid of the fraction. So 1 over 3 squared, if I bring the 3 squared up or take it out of fraction form, it would be the same as 3 to the negative 2. That way I have my bases of 3 just sitting there, which means my powers will be equal and x will be equal to negative 2. On to the next page. Question 2. Solving 3 to the power of 2x minus 1 equals 27 to the power of x. Okay, we need to write both of these with a base of 3. So the first one, let me explain that a little bit further. Because there are 2 bases here, I have a base of 3 and a base of 27, I need them both to be the same, and you don't ever want to make bases bigger. So of the 2 of those choices, 3 is the better of the 2 choices, because 27 can also be written with a base of 3. Okay, you can make it a bit smaller. So that's why I was choosing 3 as my base. So I'm going to leave the 3 to the power of 2x minus 1. The 27 can also be written with a base of 3. 27 is 3 to the power of 3. Okay, so that's the 27 part, and then that is all to the power of x. Now, technically, that is how you could write it, but with all the brackets in there, it does tend to look a little bit confusing. So we tend to just put 3 to the power of 3 is your 27, and you're timesing the 3 on the power with the x, so it's 3 to the power of 3x. Just looks a little bit nicer. Okay, so now my bases are the same, which means the top on the power on the left-hand side must be equal to the power on the right-hand side. This time it's made a little equation that I need to solve for x. So let's subtract the 2x over to the other side. So if I do a little minus 2x minus 2x, I get negative 1 equals x. Or let's put on the left, x equals negative 1. Question 3. We want to solve 5 to the power of 3n times 25 to the power of minus 2n plus 1 equals 125. So the powers that we have 2 of them. We have 5 to the power of 3n and then 25 to the power of. Okay, so they're the two bases, 5 and 25. So remember what I said last time, try the smaller number. Can I write 25 as a base of 5? And the answer is yes, it's 5 squared. So I'm going to make both of the bases 5. So 5 to the power of 3n is already correct. Then 25 is 5 squared. Now that needs to be multiplied by the power that's already there, which is negative 2n plus 1. Then on the other side of the equation, I also need to write 125 with a base of 5. So you could, again, check on your calculator. 5, well, we know 5 squared is 25. So if we increase it one more, we get 125. It's 5 cubed. Okay, so everything has a base of 5, which means all the bases of 5 can disappear, and we're going to be looking at the powers. However, on the left-hand side of the equation, we have two bases of 5 that are multiplied together. When that happens, we know we need to add the powers. So it's 5 to the power of 3n, and then we want to plus the 2 bracket minus 2n plus 1. And that's equal to 5 to the power of 3. So now we've managed to accomplish just one base of 5 on the right and one base of 5 on the left, which means the powers must be equal. So get rid of the bases, and I'm going to have 3n plus, I'm going to expand the bracket out as well. So 2 times minus 2 will make a negative 4n, and then plus 2 equals 3. 3n minus 4n makes negative n, plus 2 equals 3. To subtract the 2, we get minus n equals 1, because 3 take away 2 is 1, and then dividing the negative to the other side, we get n is equal to negative 1. Okay, so that's how you solve exponential equations. Time for you to try in exercise 3E.